Let's say, hypothetically, you want to search online for a nice, comfy, cozy, wholesome video at 3 a.m. because the only woman you know ends up being a guy. Then this guy stops talking to you after you beg for feet pics. Then you wonder how your computer was able to get that video. Then you wonder how you ended up in this place and ended up with an existential crisis. Well, no one cares about that existential crisis or you. So let's focus on how your computer does that. That is through binary. In simple terms, binary is like how a computer processes data. Before your stupid ass asks, what is binary? Well, it is ones and zeros you see in those hacker Shutterstock backgrounds. How does the input that gets processed by the computer with its own computer language turn into binary? Well, that is through a compiler, which is basically computer Google Translate. It turns the computer language into binary. For the output, the compiler does the reverse and turns the binary into the computer language. Next, let's talk about bits. Bit is the individual 1 or 0 in a string of binary. This can represent a value like on or off. Let's take an example of a clock. So you just woke up after an intense forearm session while watching this wholesome video last night. And then you see the clock says 6 o'clock. Then you check to see if the clock says AM or PM to see if your parents will beat your ass for skipping school. You see the AM and PM are both two values that can be represented by one binary bit to represent which one is on. The 6 o'clock can't be represented by a bit because it needs to be represented by multiple bits to be displayed. Instead, we can represent the 6 with something called a byte. A byte is composed out of 8 bits. The numbers we use on a daily basis is called the decimal number system, which is based on 10. This differs from binary, which is based on 2. What this means is that for each digit in the number for the decimal system, put a 10 below it. For those tens, we put it to the power 0, and for the one after that, 1, then 2, then 3, then 4, etc., etc., going from right to left. Then take the product afterwards and multiply by the corresponding number. Then add it all together and we get the same number as we started. Now we can use the same strategy for binary. For each digit in the number for the binary system, put a 2 below it. Then for those 2's, we put the power 0. And the one after that, 1. 1, then 2, then 3, then 4, etc., etc., going from right to left. Then take the product afterwards, multiply it by the corresponding number, then add it all together, and we get the decimal number. A trick for this is to think of the 0 as the off, as any number multiplied by it will end up as 0. And 1 would be on, of course, because any number multiplied by 1 will end up as the same number as a product. To convert decimal to binary, let's try 6 from our clock example. So list a few powers of 2, which is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7. Okay, then, which is 1, 2, 4, 8, 16, 32, 64, 128. Let's then eliminate the numbers bigger than 6, which would be 64, 32, 16, and 8. To eliminate them, let's put them as zeros. 4 is definitely in 6, and 2 is definitely in 6. And if you add them both together, you get 0. Not 0, 6. 6, of course. Okay, so we can eliminate the 1 also. The way we can do this is to eliminate the numbers bigger than the decimal number, then put those as zeros. After that, select the biggest number that are smaller than the decimal numbers, and add them until you get to the point that the sum is equal to our decimal number. A neat trick for this is that if the number is even, then you add the last digit as 0. If the number is odd, then you put the last digit as 1. That is because the only power of 2 that is equal to an odd number is 2 to the power 0, which equals 1. This whole trick is possible because even plus even equals even, and odd plus even equals odd. How do you convert letters and symbols to binary, or binary to letters and symbols? To do that, you have to encode different combination of segments of binary with a letter or symbol. An example of this in the AP CSP exam is ASCII coding, which is what the dinosaurs back in the 1960s used for long-distance communication. You don't have to memorize anything specific regarding the chart for AP CSP, and thank God, it is long as hell. But in some questions, you are given decimal or binary or hexadecimal in a question. Then you have to use ASCII encoding chart to encode a message. If you can't figure out how to do one of these questions, I will finally lose hope in humanity. They are really simple. You just have to take a segment you're given and then look in the chart, find the corresponding matching letter, number, or symbol, and then boom, you get that. Yeah, that's all there is to it. Like, don't need to overcomplicate it. Like, I don't know how you could overcomplicate it, but people find their way. Okay, let's get back to this. Here is another hypothetical example. And we're going to start talking about analog data here, which also has to do with binary. Here's another hypothetical example. Let's say you're listening to Sissy Hypno ASMR. And I'm not joking, this is a real ass thing. Please don't ask me how I found it though.
Because you are just a weak sissy fanboy who needs to be put in his, or should I say her, place. Your pronouns now are she and her. I feel so much better for you than being called a he, right? Right, girl, am I right? Everything that makes you feel girly is your true self, true purpose in this world, to be fully feminized, wearing panties and skirts and dresses and
So while you're listening to your questionable ASMR, you wonder how a computer is able to process data like that and turn it into binary you learned from this video. Let me answer that while you question your sexuality. Audio is considered as analog data, which is data that is constantly changing, like pronouns of a Twitter user or the position of a bird flying in the sky. In the case of the bird, its position is constantly changing. Since the data is constantly changing, it would technically be infinite, because the amount of precision it can be represented. To understand how computers process this infinite input, think of the irrational number pi, which can be represented by infinite digits, but a calculator rounds it off because at a certain point, the number of digits become pointless to represent. The computer does the same by only representing the amount of data it wants to or is necessary, because it can't reconstruct infinite data when it plays out the audio. So the computer chooses intervals in the data to represent in an analog signal. Think of choosing points to represent a wave on a graph. A higher-end device can reconstruct this audio input more precisely than a lower-end device. That is it for the complete guide on binary for the AP Computer Science Principles exam. If you have any questions, put in the comments section. Remember, Khan Academy also goes over this in the link below. Also, allegedly, if you check out the rest of my YouTube videos, you might get a big curvy 5 on your AP exam. If you don't watch Sissy Hypno ASMR, like and subscribe. If you do watch that, also like and subscribe. Please, I'm desperate and let me reach 20 subscribers. Man, should I have a 15 subscriber special? You know what, screw it. Might as well.